Hello students, read the question first. Use Euclid's division lemma. Show that the square of any positive integer is either of the form 3m or 3m plus 1 or 3m plus 2. Actually the question is, if you take a positive number, positive integer, and we have to square it, and that square can be written as 3m form or 3m plus 1 form or 3m plus 2 form. So first let us see the answer. Let a be the number, positive number, and b is 3, because a and b defined for Euclid's lemma. Therefore a is here and b we should write exactly after the equal to. So q plus r, quotient and a remainder are there. Now actually the b value is 3, therefore remainder should be less than 3, that is 0 or 1 or 2. It never be equal to 3 because it's a division. So I will give you one example. Here we have 15 and we are going to divide with 3. So how many times it can cancel? 5 times. For an example, I am going to write down it as 4 times. Now that is 12. After subtraction, the remaining 3 will be there. So again it cancel one more time. Therefore we will write down 3 cancel here in the 3 one more time. Therefore we will write down 5 and here 15. Therefore the remainder never be equal to divisor or greater than that. Okay, so remainder must be less than the divisor. So we can write 15 5 times 15, so 0. So 0 can be, or if you take 16, if you take 16, 3 cancel 5 times and it is 15, 1 is a remainder, 0 or 1. And if you take 17, so 5 times will cancel and 15 will be there, 2 is the remainder. Okay, so it is 2 is less than 3. If you take 18, so how many times? 6 times. Therefore remainder again 0. So this is the general division I have taken as an example, and here we got 3 conditions like 0 or 1 or 2. 3 never comes again because 3 is equal to the divisor, remainder is equal to divisor. Now so here we have 3 conditions, that is our remainder is equal to 0 or the remainder equal to 1 or the remainder equal to 2. So the question is, if you take any positive number, square it, that can be written in the form of 3m or 3m plus 1. I will explain. Now first let us take a equal to 3q plus 0, a equal to 3q plus 1, a equal to 3q plus 2. 3 conditions are there, and a equal to 3q plus 3 is again, it is the cyclic repetition. So take this a equal to 3q plus 0, square on both sides, a equal to 9q square, a equal to, we can write down 3 times 3q, 3 3s are 9. So I am going to separate the 3q square is a number. if you multiply, square it and multiply, you will get a number. So I can write the 3 some variable as n1. Therefore, here a square can be written as 3 of a number. That means 3n form. Now, okay, we can write a square into 3n form. Here, a is equal to 3q plus 1. So, a square on both sides. A square is equal to 3q plus 1 whole square. A square is equal to, now apply a plus b whole square formula. A square 9q square plus 3 2s are 6q plus 1 square is 1. Therefore, a square is equal to, again you just take off the 3 from the first term and the second term, take the common, again we can write down 3 of n plus 1. This is all connected to some other number. If you square it, multiply with the 3, add this term, you will get other number, but the form is 3n plus 1 form. I will explain with an example. Again, you can take a equal to 3q plus 2, square on both sides, apply a plus b whole square formula, take the 3 common, 4 can be written as 3 plus 1. Now you can take the 3 common. So here you can get a 3 some factor or the number which can multiply 3. Therefore, I can just write down the shape is, the form is 3n2 plus 1. That means 3n, n means some number, 3n plus 1, 3n plus 1, but here 3n plus 0. Let us see the original form. This is a positive integer. 1, 2, 3, 4, 5, 6, 7 and so on. They are the positive integers. Now, according to the square of any positive number can be written in this form. Shall we check? The square of 1 can be written as 1. 1 can be written as, I am going to write down 3 times 0. 3 times 0 is 0 plus 1. 2 square can be written as 4. 4 can be written as 3 into 1 plus 1. 3 ones are 3 plus 1, that is 4. Here 3 square can be written as 9. Therefore 3 times 3 plus 0. Here 4 square is equal to 16. We can write down 3 5s 15 plus 1. 5 square can be written as 25. 3 times 8 24 plus 1. So any of the square of the positive integer can be written in the form of 3n plus 1 or 3n form. This is 3n. So if you take off the 0 out, if you take off the 0, this is 3n. This is 3n plus 1. This is 3n plus 1. This is 3n. This is 3n plus 1. This is 3n plus 1. This is the 3n plus 1. Like that we can write down. Any square can be written in that form. Either one of that, 3m or 3m plus 1 or 3m plus 2. So here it is given as m. So you can write down, instead of n you can write down 3m or 3m plus 1 or 3m plus 2. M refers to a number, any number. Here you can see 3 is constant everywhere, 3, 3, 3, 3, 3. But the m is changing 1, 3, 5, 8, 12, 16, like that. That's all.